We're going to be talking about the history of XML HTTP request, and we'll also be talking about the history of promises a little bit. This is not an introduction to either one. This is sort of a high-level overview of the features and the history that go into each one, the kind of core ideas. Alex will hopefully do a follow-up presentation, which is an actual introduction to promises plus caveats and tips and tricks. So that one should be a little bit more practical than this one. This one will not be practical. He's finishing his bachelor's degree in CS, and he'll be done next month. So congrats to him. Anyway, this presentation is going to be, like I said, history and a fair bit of me ranting. So there's also some discussion points. So if you're so inclined, let's discuss, or certainly afterward on Slack. So let's start by talking about XML HTTP request, one of the most awkward names ever. We'll talk about the history of it first. So there was, in the early 2000s, DHTML was starting to gain kind of a foothold in the zeitgeist of the web community. DHTML is dynamic HTML, and it's something that is so banal by today's standards that we might even be surprised that it had a name. But DHTML is the combination of HTML, CSS, and JavaScript to do dynamic things on the page, like drop-down menus or tabs or things like that, right? Things that we do all day, every day nowadays. But back then, web pages were pretty static and pretty boring, and so DHTML was this new thing, using the DOM APIs to actually make changes to the page after it loaded. And as part of that, you would want to fetch data after a page would first load. And there weren't a lot of great options for doing this. And they were all kind of difficult to get right and kind of limited in scope. But there were ways to do it. So for example, you could hide an iframe somewhere on the page, and you could show the iframe, and the iframe could load in content, in the background. You could, this one was kind of interesting, you could load an HTML page, but because the HTML specification is very error tolerant, meaning it's completely fine if you don't close tags, you could keep the server could keep the HTTP response connection open, or it could keep the connection open after the response had been delivered, and stream more data to the page, even though the browser had rendered most of the page. It could continue streaming data, which was kind of interesting, and a little tricky to get right, but if that's what you needed, that was one of the options at the time, because the browser had no other way to load remote data, no official way, certainly. You could also dynamically add script tags, kind of like we do now, and those script tags could do various things. But again, those script tags were constrained by not having an API to load additional data. You'd have to pack that data into the script tag itself. And it's also noteworthy that computers were a lot slower back then, of course. And so the way that you would encode data into, say, a script tag really mattered, because if you had to serialize that or demarshal that data in any way, you'd pay that cost as well. So there was a project at Microsoft for the Outlook Web Access project. There was a guy working at Microsoft who was tasked with making the Outlook Web Access for the Exchange team. And he was given the option to do kind of a traditional web app, or to do something with this new DHTML that was kind of floating around. So the latter sounded like fun, and he opted to do that. And he's got a blog post where he writes up this whole history, and it's well worth reading. I'm not going to go through the whole thing, but there's a link to it in the slides. And on that note, These slides have quite a few links. So when I send out the link after the presentation, if you are so inclined, I'd recommend going through the slide notes and reading through some of the links that are in here. So it was 1998, and he needed some kind of functionality to load remote data. And he knew that the IE project was just a few weeks away from beta 2, which was their last beta before releasing, and he needed this functionality in. And he had a friend over in the XML team who he thought he could help out, so he contacted them, and they struck a deal to add this API that he had been kind of playing with to the MS XML library in order to get it in time for this Internet Explorer release. And this contact that he had was the guy who interested him in XML in the first place. This was several years before JSON was really understood to be a thing, before JSON was discovered, so to speak. And so XML was, it was a big deal in the late 90s, and this guy got him excited about it, and so he reached back out to this guy to see if he could get this API in for loading remote data, and they snuck it into the library. So that was the very first XML HTTP request, and it required ActiveX controls. We'll circle back to that because it's kind of important. But they got it into the browser 1998. Mozilla picked it up right around 2000, and then it was years later with Safari and Opera, 2004 and 2005, before they added the same API. And these browsers added it well before it was standardized. So one thing that's noteworthy about these dates is Mozilla, Netscape was in the process of dying right around this time. And so the very first Mozilla release was in the year 2000. And so they added XMLHttpRequest in that same year. It was not complete. It was not a complete implementation, and they did complete the implementation in 2002. But they shipped it in the year 2000. Safari didn't add it until 2004, but it's noteworthy that Safari wasn't released until 2003. So that's why there's the two dates on the slide. So 5 years pass, and nobody. Some people were using it in isolation. Certainly, the Outlook web team was using it, and people were kind of experimenting with the idea in a few other places, Java web applets and even Macromedia Flash, and I'll circle back to that. But if you're interested in a more thorough history of these early days, I can't recommend enough this video series by Douglas Crockford that he gave back when he was working at Yahoo, back when Yahoo had a really stellar front-end team. In fact, Yahoo was the company that put JavaScript programming on the map for me and for a lot of people as a real programming, as a real engineering discipline, because they were the very first people, at least that I remember, who would hire JavaScript programmers and call them front-end engineers rather than web developers or webmasters. And that was a sea change. Anyway, I digress. This video series is just a fantastic watch. It's all about programming, the history of computing, computers, JavaScript, the early days of the web. And Crockford is an amazing storyteller, and there's a lot of really funny anecdotes. And it's long. It's probably 5 hours, 6 hours long, but it's well worth it. If there's interest, maybe we could rent out the space on the second floor when the pandemic is over, and spend a week and just go through one of the episodes each day or something. Anyway, he makes the point in this video series that Netscape had died. They had gone out of business, and they'd kind of passed the reins over to Mozilla. And oftentimes, when there's a company that's responsible for maintaining and advocating for a programming language, when that company goes out of business, that language usually dies. And that wasn't the case for JavaScript. He thinks that XMLHttpRequest or AJAX is a big part of that. So anyway, 5 years pass, and nothing really happened with AJAX. He makes the point that there was a lot of other things that were going on. There were browser bugs, which were just pervasive back in the day. There was the browser wars. Netscape and Microsoft were competing with each other, and trying to get releases and features out as fast as possible, which of course contributes to the bugs. So he says JavaScript should have died with Netscape, but in 2005, there was a company that released a blog post called Adaptive Path, where they coined the term AJAX, and it was something that gave a name to something people had been experimenting with in various forms, for a few years. But it was the idea of combining JavaScript, CSS, DOM, and XML HTTP request, so dynamic HTML, but now with XHR, with the idea to approach desktop applications in terms of responsiveness and interactivity. But it's entirely possible that it's entirely probable that XHR was inevitable. So the author of XHR even makes this point in that history. He says, things take 3 to 5 years to kind of percolate out to the community, and people figure out how to use them, figure out what they're good for, what they're not good for. And so he's not super surprised that something that was developed incrementally in the late 90s started to hit it big in the early 2000s and exploded in 2005, and especially when it had a nice marketable name associated with it. But these things also existed in Java web applets, which were a competitor to JavaScript back in the day. JavaScript was not the obvious winner of how browsers were going to be scriptable, and Macromedia Flash as well. So Java web applets had this functionality in 2001. Flash had it in 2004. So it's probable that somebody would have come up with something similar to XHR, XML HTTP request eventually. So it eventually went on a standardization track. In the year 2006, the W3C standardized XML HTTP request, the API. Around that same year, jQuery was released, which abstracted away all of the just unbelievably annoying browser differences. And that was a big boon for the web in general, but also for XHR. And then this is noteworthy. In 2007, IE7 was released, and they adhered to the standard, which was the XML HTTP request API that we have today. Because before that, you had to do a bunch of really interesting browser sniffing tricks to see which version of IE you were on and whether or not ActiveX was loaded, because the only way you could get to this API is through these ActiveX controls, which were Microsoft specific, obviously. And so this was the very first time that an IE had shipped that API without these proprietary Microsoft-only APIs. And then from 2008 to 2011, there was an initiative called XHR2, or XML HTTP request level 2. It ended up not being its own thing, although it looked like it was going to be its own thing, like a new API. But what they ended up doing is they absorbed the additions into the original XHR spec. So that was like support for binary data. It was support for, boy, was it streaming or timeouts? I kind of forget now. In any case, they just augmented the existing API. All right, so let's talk about capabilities a little bit. So this is what the API looks like if you've never used it. It's awkward because it's a browser API, and all browser APIs are awkward. But it doesn't have to be as awful as you might have seen it. We'll get to a slide where it's a little bit more awful. But if you just need to make a GET request, it looks like this. You instantiate the class, you set up an event listener for when the response comes back. you set up the URL, the method, and any other headers or data that you want to send. And then when everything's all said and done, you call send, and it sends. If you're using callbacks, this is a very common way to use XMLHttpRequest, is to wrap it in your own function. And your own function is going to provide, an API where, this can be whatever you want. This is one pattern of many, where you specify the method, the path, any data for the request body, any optional headers, and then you pass in a callback saying when the response comes back, call this callback. But it's noteworthy that this isn't this API isn't constrained to callbacks. You can wrap this API to do whatever you need to do. Work with promises, work with observable streams. It doesn't matter. So, for example, if you wanted to wrap it with a promise, it would look like this, and you can see they're nearly identical. But in this case, we're creating a promise from a library called Q. I'll talk more about Q in a bit. And we're just calling resolve or reject, depending on whether or not it's a success or error. And that part should be pretty familiar. So there's some noteworthy features about XMLHttpRequest. One of them is that it supports cancellation. So say like I were to copy this and paste it into a browser. Let's see. So keep an eye out for the network call here. So you can see that 0 bytes were transferred because after 100 milliseconds, we canceled we aborted the request. And maybe I should show a success before I show that. But yeah, as you can see, no bytes were transferred, meaning the request was canceled. So if I run this again with a success, then we get the expected 200 back. It's 3 kilobytes of JSON data. You can also time the request out if it takes too long. And some interesting bit of trivia, our own Alex implemented the timeout API in Firefox way back in the day. And you can look through the pull request, the merge request that he sent in, not merge request, it was a patch back then. And you can see all of the crazy C++ and JavaScript setups he had to do to get it in. It was a fair bit of work, but it's awesome to have it in there because timeouts can be useful. For example, this URL, if you're not familiar with the service, it's a lot of fun to play with. It's called httpbin.org, and it can give you a variety of HTTP responses back. In this case, we're going to ask for a URL that's going to not return for 5 seconds. So say like it's a slow API, and we don't want to wait for the full 5 seconds, so we're going to time out after 1 second. So there you can see we're back to 0 bytes. The request was canceled because it took too long. There's also the progress API, which is fantastically interesting. And it works really, really well with RxJS, which I'll talk about a little bit later. But to demo it, if you ever want to know the progress of an upload or a download, you can use this progress API. So watch my console on the other right-hand side there. So there you can see it's slowly getting a response back. And we can make a percentage out of that response, saying, this is how far it's done. And I'm just console logging this for brevity, but you can imagine that we could use the same API to say, make a div on a page that had another div inside of it that slowly expanded as a progress bar. And that's not a lot of work, and this API makes it really, really easy. If you've ever used Progress API in a wrapper like Axios, for example, it is using this behind the scenes. And our RxJS has a way to access this just natively as well. But it's because XMLHttpRequest exposes this API. You can also stream changes. from a server. And this is also extremely useful for certain kinds of things. Yeah, if you want to get data back from a server incrementally. So I'll show you what that looks like. So what this is doing is this is opening a request to the server, which is going to send data over a period of several seconds. And we're going to console log, again out here to the right, what data we're getting back. So you can see that we're seeing individual bytes, but say that it could be JSON payloads or binary data or whatever else, and we can stream that in on the fly. So let's talk about streaming for a minute. With a tangent, there is an API in the browser called server sent events, and it is an official browser API and standard specification around streaming events from, or streaming data from a server to the client. Now, you guys have all heard of WebSockets, I'm sure, but server sent events is not discussed much, and it's kind of fallen out of favor. And it's a real shame because the specification is really simple and works really, really well. WebSockets are nice if you need bidirectional real-time communication. WebSockets keep a connection open, and you can send and receive data without establishing a new connection. And so for things like chat applications or games, WebSockets are essential, but they're also very, very complicated. The specification is huge. If you've ever implemented something with WebSockets, it takes a fair bit of doing. You have to really kind of understand how they work. Whereas server sent events is just plain HTTP. It's not a binary protocol. It's not something extra. It's the HTTP that you already know and love from working with the web. But it is if you only need a unidirectional stream. So say like you wanted to stream something from the server to the client, like say you were building Gmail and you wanted to know when the user in real time got new mail. Well, you can ask the server all the time, or you can just keep the stream open, super lightweight, if the server is written with coroutines, for example, to be able to manage a lot of connections all at the same time, because it's not doing anything. It's just keeping a connection open. But then when a new email arrives on the server, then you send something up this existing stream, and the browser gets the notification in real time. And one of the most amazing things about the SSE spec is it's tiny. You can sit down and read it over a lunch break, and you can implement it very, very simply. So like, for example, this is a Python, an example Python server. And you just set these two headers, and then you keep the connection open, and whenever there's data that comes through, you just spit a little JSON out, delimited by 2 new lines, and that's it. And in order to consume this on the client, you just do this. You do new event source, and then you pass in the URL. And now whenever something comes through that stream, you can just console log it out. This was never implemented in IE, but it was always really, really easy to polyfill in IE because XMLHttpRequest has this excellent built-in support for streams. So XHR is agnostic in terms of what control structures you have to use with it, and we'll be talking more about those in the next section. But say like you want to use just a simple browser like callback when a response comes back, callback. Say like you want to use a more node-style collection of callbacks. One is a success callback, one is an error callback. So you want to wrap it in a promise or in a stream or in something called a task, which we'll talk about later. XHR is agnostic. You can do any of those things, and you get all of the features that come with XHR if you do those things. So let's shift gears and talk about fetch. So the API for fetch is quite nice. You guys have probably all done this. You get a URL. If it's JSON, it's got built-in support for JSON. XML HTTP request obviously predates JSON, so You can add it, of course, but with fetch, it's right there, it's built in, and it's all promises. So the API is very, very simple comparatively. Oftentimes, you'll want to do something a little bit more like this with fetch, where you're looking to see if the response is okay, and this is something the fetch API just bakes in. This is an opinion on what HTTP status code is success and which one is failure. So it's a nice shorthand. And so you can say the promise is a failure if it's not okay, otherwise continue going. You can check the response headers. If you get JSON back, then parse it as JSON, otherwise don't. And then you can catch the error. And one of the noteworthy things about promises, which we'll circle back to, is this little catch here at the end is optional. And if you leave it out, it can lead to some pretty frustrating bugs. So keep an eye out for including that. But anyway, fetch. It's still a pretty nice and simple API. But one of the problems with fetch is it only implements a subset of what XMLHttpRequest does. It's missing everything we've talked about: abort, timeout, stream, progress, streams, and it is directly tied to promises. So if you want to use any other thing, you're kind of out of luck. You're stuck with promises as the lowest common denominator. There are streams that have been implemented, but IE 11 hasn't picked them up yet. And I expect the fetch API will continue to grow and pick up the features of XMLHttpRequest over time. So it's kind of disappointing in its current state, but I expect it to get better. It'll always be with promises, but I expect it to pick up these other features. So, but that's kind of a big downside, the promise-based downside. Say like you wanted to wrap the fetch API in RxJS, then you would not have all of the bells and whistles of XMLHttpRequest available to you, such as streams, for example. And even if they were to add streams, you'd always be stuck with the single response of the promise, because a promise is just going to be that single value. And so this brings me to kind of a point, which is whenever you have any AJAX library, and that could be XMLHttpRequest, that could be fetch, that could be Axios, that could be whatever, that could be RxJS, you always, always, always wrap that library with application-specific code. As of this year, I've been doing web development for 20 years. And in my 20 years, I have never, ever, ever written, used an AJAX library without wrapping it in some kind of application-specific API. So it's just not a thing. For example, when you send a request to your server, there's going to be a fair bit of boilerplate, even with the fetch API, as we saw, that you're going to want to abstract away into a single function call. You're going to want to do things like add common request headers. You're going to want to send the request as JSON. You're going to want to authenticate the requests. Maybe you're adding an authentication header, or maybe you're opting into sending and receiving cookies from the server. Maybe you want to enable CORS. Maybe you want to add an cross-site scripting token to the request because your server is sending one and it's going to reject your request if you don't include it. You always want consistent response parsing. So you want the application code in your JavaScript to be able to take a response given a whole bunch of possible criteria and deal with it in a consistent way. So for example, if you're using JSON as the thing you're sending and receiving, you always want to parse it as JSON. And then of course fish for errors if it's invalid JSON. You want to handle redirects. Those crop up from time to time. You want to handle things like no content responses. If you send a post request and it's going to take a little while for the server to process it, it might send you a 201 back saying, yep, we created the thing, but it's not going to give you any more data. You have to follow up when it's finished. This is every application ever that has authentication, right? If you send a request to the server and that request has not been authenticated because the user hasn't logged in yet, for example, you're going to want to be able to handle that in the UI and pop up a login dialog. You're going to want to differentiate between success and error responses. Is a 400 response from the server, is that an error all the time? It really depends on your application. If it's something like a 500 error, maybe you want to put a little banner up at the top saying there was a server error and there's nothing more that can be done. If it's a 400 response, you probably want to handle that differently and show that to the user, saying, hey, the form validation failed or something like that, right? Every application is going to have application-specific things like this. And if you go far enough, you can do things like cache the data manually in the browser, and then do things with that in-browser cache. So, for example, you can send follow-up requests that use that cache, or look to see if anything is new. So you're saying, this is the last response that I had. This is the thing that I have cached. Is there anything that's been added on the server since the thing that I got? The server can send you a really lightweight yes or no, but you have to have the data available to ask whether or not you have whether or not the server has something new. And so these are really, really common for large applications, and so you're going to wrap it. You're going to wrap XHR, or you're going to wrap fetch. It's going to happen, and you're going to have something like this, from your application utilities folder, import Ajax, and then do the thing. And is it using XHR or fetch behind the scenes? Well, it kind of doesn't matter, right? If it suits your needs, then it doesn't matter what's being used underneath the hood. As long as it meets your business use case, and as long as the primitive that you've opted into is going to be a good primitive for you going forward. So, for example, if you're good with promises for the life of your application, then that's obvious. If you'd rather use streams, then that's less obvious. But say like you're using XHR or jQuery or Axios, if you're wrapping any one of those things, it kind of doesn't matter which one you use. The implementation should be, you can swap out jQuery for Axios, for example. And that's called the facade pattern, and it's just a nice pattern for this kind of problem. All right, let's talk about promises. So before there were promises, we had callbacks. There's two kinds of callbacks. One is blocking callbacks, which you guys have used with map, filter, and reduce. These are synchronous callbacks, and they're implementable in a variety of languages like pointers in C, or if you're using a language that has first-class functions, then you can just use first-class functions. And there's a variety of ways to implement them. You can also do asynchronous callbacks called deferred callbacks. And these are something that you're already familiar with that you would use with set timeout. In other languages, these might run functions on different threads or processors, or in the case of JavaScript, different queues. And we'll talk about the different queues in a moment. For the rest of this presentation, we're only talking about asynchronous callbacks. We're not talking about synchronous callbacks at all. Conceptually, they look kind of similar, but the implementation details are wildly different. So, continuation passing style. You might have heard this word already. It is an API style that first showed up in 1975 in Scheme. And what it did is it made program control flow explicit by, when you would call a function, you would give it a continuation to say where it should go next. And that was kind of an interesting API in a lot of ways. the chat. That was an interesting API in a lot of ways, but not all of it is applicable to what we're going to be talking about with JavaScript. There is a whole presentation or three that could be given on continuation passing style. It is pretty amazing in a lot of ways, but the callbacks that we're going to be talking about are a small subset of true continuation passing style. But one of the APIs that, that was enabled by continuation passing style, and I'm not going to get into it here, but suffice it to say, in order to implement continuation passing style, your programming language needs to have a certain set of features. But if it does, then you can use this API to provide a huge variety of other kinds of APIs. So for example, in promises, you're familiar with the race operator, or in Rx, we call it the ambiguous operator. You can do backtracking and coroutines and generators and engines and threads and try-catch expressions. You can break a long computation up into chunks. So say like you're running some kind of heavy computation on a single thread and you don't want to block the thread, you run a little bit and then you pause, and then you run a little bit and you pause. And in between those pauses, you give control back to some other scheduler that lets you it do other things, that gives it the appearance of not blocking the thread by breaking that up. And all of those things are pretty amazing things by themselves, and they're all possible through this one API, which is pretty incredible. But they are a little hard to write and maintain. It kind of requires that you write a program from the inside, or an expression from the inside out. And so they're hard to write, hard to maintain. For that reason, especially in functional languages or languages with tail call optimization, continuation passing style is sometimes a compilation target, meaning you write a program in one format and it gets compiled to continuation passing style, and then the compiler and the engine that runs that can do things a little bit more efficiently. In 1976 and 77, promises and futures were first described in a format similar to how we know them today. It was academic research, again in Lisp, and then about 10 years later, in 1988, another paper came out with promise pipelines, so the .then chaining that we know now, and so those were semantically promises like we know and use today. And the links to all of these are in the slide notes for this particular slide, but they've got a good pedigree, obviously. And one other thing from the 1980s and the 1990s is monads. Monads are a mathematical concept from category theory, and there was a lot of research into how they could be used in functional programming languages. And that happened, a lot of that work, a lot of that early work happened in the 80s and 90s. On that note, Lisp and Scheme and the ML family of languages are kind of interesting. If you pick up a book on any one of these languages, from the era, a book that was written in those early days. And I read, I skimmed, I should say, I read parts of several of these books earlier in the year, around January, February. And every book that I read started off with this caveat, this kind of apology, saying, the concepts we're about to teach you in this book are not weird. They can be used to solve real programming problems, and they might feel weird at first, but go with it, and there'll be a payoff in the end. And I don't know, it was kind of weird that they kept making these apologies. It was weird to me that they kept making these apologies over and over, because the concepts didn't seem that weird to me, and I realized that we take all of these ideas for granted nowadays. They were trying to explain first-class functions and higher-order functions and principal function composition, and we do these things all day, every day in JavaScript nowadays, and so they're just not weird anymore. Hopefully, JavaScript will get tail call optimization as well. It was in the 2015 spec, but no browsers have implemented it, even though they've implemented the rest of that spec. So hopefully they'll get around to that, and that'll open up a few more interesting patterns to us. All right, then promises. So one of the problems with callbacks is what's called the pyramid of doom. You guys are probably familiar with this, where the white space here in the left forms a pyramid. And these are really tricky to get right, because not only do you have to get the indentation right, but you have to pass in the thing that handles your errors separately at each and every level. And so this is kind of tricky to get right. So the Promise API solves that very, very handily by composing these callbacks in a principled, structured way. So promises I think you guys know, have three states. One is initialized, where you get or create the other promise. One is resolved, which is when that promise has a value, and one is rejected when the promise has an error. Once the promise is initialized, it's in flight. There's nothing you can do about that. So if this had a set timeout in the middle, that set timeout would be running at this point. If it was fetch, then that fetch would be running. You have no control over when that happens. As soon as you have a promise, it's off and running. So you have no visibility into what current state it is. You just have to call .then and .catch, and whichever of your callbacks gets run is what state it's in. It also does caching and control flow. So for example, if I were to run this, you can see that it makes one network request, but it console logs 3 times. So it's caching that response data for us, which is pretty useful. Unfortunately, you have no visibility and no control over that cache. You can't refresh it. You can't do anything to it. If it's stored in that my user's variable, the best you can do is dump the variable and recreate it. Promises are always async, even if they're already resolved. This makes them consistent to use. So let's see, quick note about, there's a few different kinds of asynchronous queues in JavaScript. There's a task, which is a single run, a single turn of the event loop. The event loop is probably worth its own presentation. You've got a micro task, which is a queue of things to run during one of those turns of the event loop. So and JavaScript maintains a queue of things to run in each instance. And then there's also a request animation frame, which is a separate queue that's useful for rendering. Promises use microtasks. Set timeout uses tasks. And that's well worth diving into, but we're not going to get into it today. If you want to get into it, this website, link is in the slide notes, is a fun website to click through. And it talks about the different kinds of queues. And it has interactive demos that you can play around with the different kinds of queues. And one of the things that it talks about is how some of the browser implementations are different from one another. So you might expect one browser implementation to be using, or you might expect a browser to be using an event when in fact it's using, a task when it's using a microtask. So one of the things the post asks is which browser is right? You know, which browser is most adherent to the specification, which is an important question to ask from an academic or a browser implementer point of view. But for the end user, one of the points the article doesn't make that if you read it, I definitely think you should pay attention to is it kind of doesn't matter which of the browsers are right from the end user, your perspective as you're trying to use things, because none of these things are deterministic. You need to use a control structure on top of these things to make something deterministic. If you need something to happen after something else, the worst possible way to do it is to set a set timeout followed by a set timeout with a slightly greater increment, because it's just impossible to juggle. And in the case of some of the things this article talks about, it is different between browsers, and so you just can't know. So if you use a library on top of these APIs to make it deterministic, your life will be a lot happier. So promises have a lot of problems, and I've talked about a few, and I'm going to talk about more. And they didn't have to be this way, which is why they're kind of disappointing, but they are. So there are many, many variants of async control structures. So we've talked about a few already: promises, deferreds, tasks, futures, reactive streams, FRP streams, callbacks. I'm sure I'm missing some. And promises chose a specific kind. And on top of that, the promises that we have in the spec differ a little bit from some of the promise libraries that had existed at the time of the spec. So one of the most popular ones was called Q, and it had progress events. It forced you to handle unhandled errors, or it would handle them for you, I should say. You didn't have to, if you left out that catch that we talked about at the end, it would still handle that gracefully. You could introspect the current state that the promise was in. With Bluebird, you had progress. Again, you had cancellation. With the Win library, you had a whole host of operators like you would have with RxJS, and some of the features. So the promises that we have natively in the browser are kind of the least interesting of all of the promise libraries out there. And they were made to be simple, but it was also kind of a missed opportunity. So there was a GitHub discussion where some people chimed in, and they asked the people that were making the spec to consider some additional ideas that would make promises a little bit more versatile. And they got some pretty amazing pushback by one of the guys involved in the spec, Dominic Denicola. Now, he's been in the web community for a while, and he's done quite a few things. And so on one level, he deserves our thanks for the hard volunteer work he's put into the ecosystem. But anecdotally, whenever I see him engage in a discussion online, he's flaming somebody. He's responding a little bit more extremely than I think maybe is warranted. Anyway, so somebody was asking about adding some features to the promise spec, and this was his reply. And one of the things he mentioned is it totally ignores reality in favor of typed language fantasy land. And he kind of missed the point, but one of the interesting things about this discussion was the people that were pushing for this took this to heart, and they went ahead and created the Fantasyland specification, which is what's called an algebraic JavaScript specification. And what algebraic means in this context is that it follows some mathematical rules, meaning if you have a construct that follows these rules, then the behavior of that construct and how that construct can be associated with other things is a known quantity. So for example, the thing that they were proposing is something called monad. And you don't have to know all of these things to know how to use the concept that they're talking about. It's just useful for people that want to go below the surface or want to implement their own libraries. So for example, they were asking the promise team to add to make promises adhere to the monad specification. And if they had, then what they would get automatically is the applicative specification, the chain specification, the apply specification, and the functor specification. So you can kind of follow the arrows backward. And you can see that by implementing this, then you get all of these other behaviors for free. So for example, the applicative behavior is something that allows you to parallelize to asynchronous operations like promise.all. Promise.all is something you get with the monad specification kind of for free. And that was kind of their point. So let's talk about some things that promises got right. Function composition. So whenever you do dot chaining with functions, then you are doing function composition. So say like we wanted to capitalize a word, or excuse me, uppercase a word, and then we wanted to add an exclamation to the end, then we can do the dot chaining with the then, and we end up with capital foo exclamation mark. And that is the exact same thing as if we were to implement the compose function from functional programming, and we were to compose the exclaim and capitalize functions together, and then just call a single then. The result is the same. So whenever you're chaining maps or chaining thens, you are doing function composition. And function composition is amazing because that's how you make complex big things out of small simple things. But it got it wrong when it only introduced two ways to compose promises themselves. You can compose them with all and race. So all waits for all promises to finish and then gives you a single value with all of the results. And race gives you whichever one completes first. You can add more operators, but it's a little bit difficult because they also auto-flatten promises. Now, this takes a little walking through, but let's try. So what we're doing is we're making a timer, which is returning a promise with that calls set timeout, okay? So what we want is we want to wait 1 second. But there's no way for us to create a promise and then pass it down the chain, to generate a promise on the fly and then pass it down the chain, because as soon as we generate it, it's in flight. And even if it wasn't, the then would flatten it out and consume it and make it in flight before it passed it on to this then. So there's no way for us to have this inner promise.all wait for a single second. So it runs them in parallel, and we wanted to wait for a single second, but instead we're going to get 2 seconds. As you can see. And that's just not a thing that's possible with promises. The other thing is something I've alluded to already, which is eager execution. If you wanted to compose two promises, you can't do so without having complete knowledge of when that promise was created. So for example, in this one, we want it to wait for 1 second, okay? So if I were to copy and paste this in here, it would wait for 1 second. But that's only because I happen to copy and paste this right above this. If we had gotten this promise from some other part of the code, maybe a Webpack import or some other place, then all bets are off as to what this is going to do, because promises just care about when the thing is finished, not the thing that it needs to do in order to be finished, that time it takes before it's finished. And that makes it pretty much impossible to do any kind of meaningful composition of promises. But it didn't have to be that way. So this is an example of an API called a task. A task is lazy. It is not eager like promises. And this is a partial implementation. You can do parallelization, as we've already talked about. In this one, I'm just implementing operators to do the sequential operation. But I can show you what that looks like. So if we were to pull in our task implementation there, now we can do something like you can do with promises. So in this case, we're going to do a thing for a second, and then we're going to wait for that to finish, and then do another thing for a second. So this should wait for 2 seconds. Okay, there we go. There's our 2 seconds. So in that case, it works like a promise. But say like we wanted it to do something else. Say like we wanted to generate 3 timers. So here we are, we're running a map function on an array to produce 3 timers, each of 1 second, right? And then we want to pass that to the next operator in the chain. So in this case, chain is effectively the equivalent of then and a promise. But map is not. Map does not automatically consume these inner promises. And they're lazy, so we can just pass them down. And then in here, we can do this pattern, this reduce pattern. And this is a promise, or this is a pattern you'll see with promises as well. If you've got a bunch of promises and you want to make them happen in serial order, oftentimes people will have you run a reduce on them, where you're building up a promise, then promise for serial execution. So that's what we're doing here. Except now, these things are consumed one at a time. And so we get 3 seconds like we wanted. because they're not eager and because they're not flattened. And so that's an example of one of the kinds of things you can do. It seems a little abstract on a slide, but I come up against this need semi-frequently in the code base here at MX. We've got multiple examples of using RxJS to do this exact thing. So promises don't model a request response cycle very closely. So you can have three possible states in a request response cycle. You can have it's not yet requested. You can have it's in flight, like it's loading, and then you can have it succeeded or it failed. And a promise will help you with that last one, but it won't help you with the other first two at all. And there are other control structures that will help you with this. I meant to pull this up beforehand. Sorry, let me pull it up real quick. Yeah. So here's an example of using RxJS to build control structures that can handle that. So you can see here it's randomly succeeding or failing, but the control structure is modeling that life cycle very plainly. So if it's the initial data, then it's got the little get button. If it's loading, it puts up a spinner. And if it succeeded or failed, it did that. And the control structures, like a promise, are all local. So those four possible states, or three possible states, live right next to each other in the code. And I'll paste that into the channel if you want to examine it more. So here's a tangent about streams. With RxJS specifically, it does all of the things that we've talked about beautifully, and then some. This is one of the reasons I'm such a big fan of it. It's very composable. It gives you granular control over the caching and the control flow from top to bottom. It gives you granular control over what kind of asynchronous function call it is, initialization, resolving multiple times if you wanted to, with progress, for example, reject, canceling, timeouts, progress, all of that stuff. It does it beautifully. But I'm an Uber fan, but I don't want that to detract from the idea behind these implementations. There's a whole bunch of stream APIs that are as every bit as production ready as RxJS. Most is very impressive. Xstream is simple and got a lot of popularity in the CycleJS community. There's another one called Floyd. These ideas are not just Rx. So I don't want it to make I don't want it to sound like because I'm such a fan of Rx that's the only thing that we should use. The ideas that Rx brings to the table are the same ideas that Task brings to the table and the Fantasyland specification brings to the table. And these are the ideas that allow you to do complex things. Promises were designed to be simple. And they succeeded in that, probably, but we do this for our day job, day in, day out. And so we have complex needs. And it's nice that we can get people onboarded to the idea of promises easily. That's a one-time cost. You onboard somebody to a promise one time, and then they get it. But then you have to spend the rest of your career using them when they've got all of these downsides, whereas other implementations might not. So let's talk a little bit about the future. Sorry, we're going to go about 10 minutes over. I'm almost done. Let's talk about language features versus user space. Whenever you add features to a language, it makes that language harder to learn. It makes it harder to expand. It makes it harder to maintain. And that's especially egregious when those features could live in user space as a library. So we had promise libraries, and as we've already discussed, they had a lot of features that were more interesting than the promise implementation that we got as part of JavaScript, the language. But, and there's a cost to downloading a library, of course, but there needs to be a high barrier to entry to adding something to a language, because once it's added to the language, you're stuck with it. It becomes several orders of magnitude harder to change over time, to augment, to fix, to do anything with, because because it affects everybody by default. Whereas user space is a great place to kind of explore ideas, what works, what doesn't. And if something has been baked, truly baked, over the course of many, many years, then that might be a good time to bring it into the language. And promises were decidedly not that when they were brought into JavaScript. There was still a lot of interesting experimentation going on in the space. Even though promises and monads come out of the 70s and the 80s, it took other languages quite a long time to kind of figure out how to adopt them and where they're useful and where they're not. And that exploration is still ongoing. And it would be nice to have that in user space rather than cluttering the language. And and promises did not require new syntax. They did not require a syntactical addition to the language. We'll talk about async await in a minute. But that was another thing is if you can implement this thing, this thing that you're exploring without having to add anything to the language, using the existing features of the language, like first-class functions, like continuation passing style, then you have everything you need to do that exploration. You don't need the language to help you out. You're empowered yourself. You're not relying on language designers or compiler designers or implementers or browser implementers. You can just do it yourself. So let's talk about async await briefly. They are promises. Async await is promises. It is syntactic sugar around promises, period, full stop. They have all of the downsides of promises because they are promises, and they might, they're syntactically different. Some people might find them a little bit easier to get started with than promises, but make no mistake, they are the same thing. So if you get deep into one, you're going to have to know the other because they're the same thing. And I think there's a debate worth having about whether hiding something that is async, making something that is async look synchronous, is even a valuable end goal. It is an abstraction, right? You're trying to abstract away complex async operations. But I personally have never seen an implementation that wasn't a leaky abstraction. And so you ultimately have to know that that thing is actually async. And you kind of have to know how the async works under the hood in order to use this thing effectively without shooting yourself in the foot. So it might be possible that that the end goal was never a valuable end goal in the first place. We want to make asynchronous stuff easier because that's one of the hardest things we have to do, and we have to do it day in, day out. And that's all of JavaScript. But making it look synchronous might not be the way to make that user-friendly. So both of there are two people that are responsible for the bulk of my JavaScript knowledge: Douglas Crockford and Reginald Braithwaite, who goes by Regenwald. Reginald Braithwaite wrote the book JavaScript Allongé. I've talked about it in previous presentations. If you're ever looking to step up your JavaScript game, I cannot recommend this book highly enough. It is incredible. It's one of those books where I came out of the other side a different person, thinking about problems in a different way. And it's an incredible book. And I learned how to use JavaScript from Douglas Crockford's famous JavaScript, the good parts, of course. So these two guys have been fundamental in my journey with JavaScript, and both of them would prefer to see JavaScript as a small, lean language without a lot of syntactical additions and things that are going to clutter the language, things that are going to make it hard to augment the language, there is a time and place for adding things to the language, but like we've talked about, there needs to be a high barrier to entry. And the more you add, the harder it is to add new things. And anyway, they both harp on this. Douglas Crockford gave a presentation, or was interviewed on the podcast JavaScript Jabber, done by some local people here in Utah. And that's well worth a listen. That was just a few weeks ago, a month or two. And this presentation, which is linked in the show notes by Reginald Braithwaite, is again just a fantastic watch. He talks about the good parts of adding things to the language and the drawbacks of doing so. Both of them are advocating to keep it small, and that's certainly my opinion as well. But that is just an opinion, so it's maybe worth having a debate going forward. Thanks for sticking with me a little bit over time, and thanks for coming. You're welcome to ask questions, or we can move questions over to Slack. Slack it is. Thanks a lot. Thanks for coming, everybody.